that this will not happen in the future. Okay. So last week we started talking about atoms and what makes up an atom. The very first week we talked about types of pure substances. We said there are two types of pure substances. Does anybody remember what they are? Compounds and elements. So an element is just an atom, right? That's up there. A compound is when you take multiple elements and you put them together. That's what we're going to talk about today. So we started small, and we're going to work our way up. There are two types of compounds, ionic and molecular. It's going to be a really easy way to tell them apart. An ionic compound is made up of a metal cation and a non-metal anion. That metal cation is the key. If you look at a compound and there is a metal in it, anything from the left to the left of that stair step, it is by default an ionic compound. If there is no metal, it is by default a molecular compound. Okay? So the very, very first thing you do is look for the metal. And I'll tell you which type of compound it is, and then each type of compound has its own separate rules. When you look at how much of each cation and anion there are, they're always in a strict proportion. And they're in that proportion so that as a whole, there's no charge. And you'll see how that works. The ions, they arrange very neatly in a crystal lattice. It looks like blocks stacked together. Ionic compounds are called salts. In this class, salt has a bigger meaning than it does anywhere out in the real world. Out there, if we walk on the soccer field and just ask someone what salt is, what are they going to say? Right. But we know what actually is that you put on your food. Sodium chloride. Sodium chloride is a salt. It is by far the most common salt, which is why it's called salt. Molecular compounds, like I said, have no metal in them. Carbon dioxide, carbon and oxygen. Here's just oxygen, O2, CO2. There's no metals. It's a molecular compound. They have no charge because there are no ions. Ionic compounds are made of ions. Molecular compounds, there are no ions. So each individual atom starts neutral. Once you put them together, they're still neutral. And molecular compounds are molecules. They are not just crystal lattice. They are individual little molecules. I'm going to skip. These are just properties of ionic and molecular compounds. This is a crystal lattice. That's sodium chloride. If you look, the little ones are going to be sodium. The big ones are chlorine. Just alternating. CO2 is a molecule. Oxygen is a molecular element. It's a molecule also. So CCl4, ionic or molecular? Why? Where's the metal? It's molecular. Both carbon and chlorine are nonmetals. What about calcium, this one? It's ionic. Calcium is a metal. Calcium way over here, that's definitely a metal. This slide, you have to refer back to that table. We're not going to take the time because it's in the video if you want to see it. Important, when you dissolve an ionic compound in water, it breaks apart. Sodium chloride is made up of sodium ions and chloride ions. When you put it in water, it breaks apart into those two. And at that point, they're completely independent of each other. And that's going to be important in future lectures. Opposite of that, molecular compounds do not break apart. Sugar is a molecular compound, it's sucrose. When you put it in water, it doesn't break apart. It is still a sucrose molecule. It just starts floating around in the water. This is methanol. Methanol in water just goes from liquid methanol to aqueous methanol. It didn't break apart into CH3 or OH or any smaller parts. Okay, that was the video. There's more details in the video. I really suggest going home and watching that if you struggle with any of this at all. So we're going to start with the ionic compounds. Ionic compounds are made of ions. There are two types of ions. There's monatomic ions and polyatomic ions. Just as the name makes it sound, monatomic ions are ions that are made of one atom, monoatom. We learned about forming ions before. So if I have magnesium, what ion is that going to form? What charge?
+2.
+2. Why? It wants to lose 2 so it can go backwards to a noble gas. Right? So we talked about how group 1 forms +1 charges, group 2 forms +2, this one over here forms +3, and we kind of glossed over these. I said most of them form +2 charges. Unfortunately, saying most of them form +2 charges isn't going to be good enough today. So we're going to have to look at some of those exceptions. So these are names of some monatomic ions. That's oxygen ion, it's called oxide ion. So just look at these and see if you can find a pattern. There's actually 2 patterns.
The negative ones are ions.
Yes, exactly. So that's the one pattern.
And then the positives are the UN, yeah.
Well, so it's sodium, magnesium, potassium. I guess.
Aluminum's probably 3.
Yeah. So you're actually, that pattern is correct with these examples. What if I had, do they all end in UN? What about copper? Copper does not end in any UN. Okay. So if copper was up here, it would be called copper ion.
Would it simply be with the ending doesn't change on all of them?
Exactly. It's just the element. It's the element with the word ion. So it's sodium ion, aluminum ion, magnesium ion, potassium ion. The negative ones, you take the ending off and you put the I on. Oxygen becomes oxide, nitrogen becomes nitride, chloride, fluoride. What would you call a sulfur ion? Sulfide. What would you call a scandium ion? Scandium ion. It's a positive, so you just put ion on the end. What about bromine ion? Bromine. Okay. That's all there is to the monatomic ions. I put this in here. These are the ones that you're going to run across the most often. You don't have to memorize these like you did the elements, because we just learned the rules of how to name them. What's that one called? If that element is rubidium. I don't think I had made you remember that one. It's rubidium ion. And what's that one called? Phosphide. Okay. So these are the ones you're going to run across the most often. But when I make questions, if I just stuck to these, it would get very boring and it would be really hard for me to write questions. So you will see some that aren't up here. Where it gets a little more complicated are the polyatomic ions. A polyatomic ion is an ion, but it's made up of multiple atoms. So this is sulfide. That's just one sulfur atom that gained 2 electrons. So it now has a negative 2 charge. This is sulfite. We have the same sulfur, but there are 3 oxygens on the outside. This is sulfate, sulfur with 4 oxygens. They all have a 2- charge. They are all anions, and they're all actually going to behave the same. Any ion that has a 2 negative charge is going to behave the same. They're interchangeable. The fact that this one has 5 atoms in it is irrelevant in terms of what they do. What it changes is the name. So we have sulfide, sulfite, and sulfate, and we'll see where those suffixes come from. A polyatomic ion that has oxygen in it is also called an oxoanion. That's not an important statement. I will not test you on that. It is in the learning objectives for the course. Here it is. These are common oxoanions. Nitrate ion, nitrite, sulfate, sulfite, chlorate, chloride. Do you see a pattern in those? The 8s have more oxygens than the ites. Is there a pattern in how many the 8s have? How many does that one have? How many does that one have? 4. That's a trick that people get stuck on. They get in their head that 8s have 3. That is not always the case. 8s have more. The 8s are defined as sort of the starting point. Once you take an oxygen off, you go from 3 to 2, or 4 to 3, or 3 to 2, you go from 8 to 8. So, I think, so on campus, on Canvas there is a file. It's polyatomic ions and oxoacids you need to know, or something very, very similar to what I just said. That's the file name of it. It's a little table with ions and acid names. That's what it looks like. These are the polyatomic ions. We'll get to the acids later today. Don't worry about these at the moment. Those are the polyatomic ions you are required to know the names of. Okay? So the way I would do it is you don't have to memorize all of these. If you memorize nitrate, and you remember that nitrate is NO3 minus, and you see NO2 minus, you can say that's one less oxygen than nitrate, it must be nitrite. So you can just remember nitrate, sulfate, and chlorate. And then the ites, just go with them. You can figure them out if you run across them. These other ones, there's no way of getting around. Hydroxide, carbonate, bicarbonate, so it can also be called hydrogen carbonate, or ammonia. We're going to see these a lot. So you're going to want to know those. Let's look at pattern naming compounds that have a polyatomic ion. This one is calcium carbonate. This one is sodium bicarbonate. Do you see a pattern yet? What's the pattern? It's in the names. So, well, let's look. What are the two ions in this compound? There's calcium ion, and what's this one? It's carbonate. You don't have your ions memorized yet. If you look back, CO3 is carbonate. So we have calcium and carbonate, and we call that calcium carbonate. This is sodium bicarbonate. There's sodium, that's bicarbonate. It's called sodium bicarbonate. What's the pattern?
It's the metals and the metals.
Say it again?
Metals and the metals.
Right. So you're not changing anything. With polyatomic ions, the name is the name. You have carbonate, carbonate, bicarbonate, bicarbonate. This one is not included on your list, but this is cyanide. Cyanide, sodium, cyanide. Potassium nitrate is called potassium nitrate. So naming them is just a matter of remembering the names for the polyatomic ions. If you can remember that, just put the two together, and that is your name. There is only one common polyatomic ion that has a positive charge. That is ammonium. This will trick a lot of you up. Ammonium is NH4+. Ammonia is NH3. Don't get those two mixed up. NH4+ is ammonium, NH3 is ammonia. So, if we put two polyatomic ions together, what's this one called? Ammonium. What's this one called?
Nitrate.
Nitrate. Together it's just called ammonium nitrate. You don't have to put the ides, you don't have to worry about the eights or the ites. Once you figure out the name of the ion, you just stick it in there. Polyatomic ions and the monatomic ions behave identically. This is the crystal lattice for sodium chloride. This is the crystal lattice for calcium carbonate. They just alternate. Here you have chloride, sodium, chloride, sodium, chloride. Here it's a lot harder to see, there's a lot more going on, but there's one of these for every one of these calciums. They alternate. Just 1, 2, 1, 2. They just form a little block. This is another slide required to show you. I won't test you on it. Binary, tertiary, and quaternary compounds. A binary compound has 2 different elements in it. Tertiary compound has 3 different elements in it. Quaternary has 4. It doesn't matter how many ions there are, how many polyatomic, how many monoatomic, whether it's ionic or molecular. Just look at the formula, count how many different elements there are, and that'll tell you whether it's binary, tertiary, or quaternary. So we can go from an atom to an ion. And we saw names of ionic compounds in the formula. We could kind of see where the two went back and forth. But in all of those cases, there was always an equal number of the anion and the cation. It was always 1 to 1. That is not the case. We said a few slides back that when they combine, they have to combine so that there's a 0 charge. So what happens if I take a sodium ion? What charge does sodium ion have? +1. And I put it with a sulfur ion, sulfide. What's the charge on the sulfide ion? -2. So what happens if I put those together? If I put one of these with one of these, what is my net charge, my total charge once I put them together? -1. +1 and -2, put them together, you still have -1. So what can you do to cancel out that extra negative? Add another sodium. So you're going to have Na2, 2 sodiums with 1 sulfide. So this is when you can actually write it out in terms of an equation. Total charge from the cations. So take the charge on the cation, in our case it was sodium, multiply it by however many you have. So we had 2 sodiums. So you could say 2 times +1 plus how many anions did we have? How many sulfides did we have? We had 1, and what was the charge on that sulfide? -2. So what is 2 times +1? 2 times +1? 2. What is 1 times -2? -2. What is +2 plus -2? 0. So these are some ways that you can do it. This is sodium chloride. They both started with a +1 charge. So just right off the bat, they cancel each other out. So it's 1 to 1. This is calcium and nitrate. Calcium has a +2 charge. It's in group 2 here. Next week, once you know your polyatomic ions, you'll know that nitrate has a -1 charge. So we need 2 of these to cancel out the 1 calcium. There are 2 nitrates for every calcium. But in our formula, we have to write that. We have to specify that it's not equal proportions anymore. So we put calcium, then we put nitrate in parentheses, we put a 2 outside of the parentheses. That means that there are 2 of the unit that's inside the parentheses. That's saying there are 2 nitrates. That is not saying that there are 6 oxygens and 1 nitrogen. If you actually worked it out, you'd have to put the 2 there and multiply the 3 by the 2. There are 2 nitrogens and 6 oxygens. But they work as nitrate units. So you have to write it out as saying there are 2 nitrates. Does that make sense? Questions on that? Next one. We have sodium sulfate. Sodium has a +1 charge. Sulfate is a 2- charge. So we need 2 of the sodiums to cancel out our sulfate. So we write that as Na2SO4. You don't need the parentheses because the sodium ion is only one thing to begin with. We only need to put the parentheses if we're talking about a unit that's made up of multiple things. Here's barium chloride. There's no polyatomic ion here, but the barium is +2, the chloride is -1, so we need 2 of them to cancel out the 2+ on the barium. So we write that BaCl2. And here's about the most complicated you can get, barium phosphate. Barium has a 2+ charge. Phosphate has a 3- charge. What happens if I have barium and phosphate? What is my net charge then? -1. So in all of our other cases, we were able to just say, well, we need 2 of one of them. So what happens if I have 2 bariums? What's my net charge? Is that okay?
No.
No, it's not okay. So let's say, okay, well, what if I have 2 phosphates? Is that okay? What's my net charge? -4. So, well, what if I have 2 of each? Still -2. And so what is my total positive charge over here? 4. So we have 4 plus, what's my total negative over here? Got 6 minus. So you see how there's just 2 different here. Our bariums each supply 2 plus. So if I go Ba 2 plus, what's my net charge? 0. Now it's 0. So in this case, you kind of had to have multiple of each of them so that you could get the same number. You needed 6 on both sides. It's a common 6 is a common multiple of 2 and 3. So if you want to conceptualize it, this is exactly what's going on. There is a shortcut to do this. So let's try the first one. We have calcium and nitride. How do I write calcium ion? Ca2 plus. How do I write nitride ion? So nitride is not a polyatomic ion. It's just nitrogen becoming an ion. If you have N3 minus, it's going to behave just like any other element. Remember, these form -1, -2, -3. So nitrogen forms a -3 nitride ion. Is my net charge 0? No. So you can either do it the way we just did it, and really sit down and think about it. Or you can do this little trick. Take this number, take that number, whatever it is, write it here as a subscript on this one. Take this number, write it as a subscript on that one. So what we get is Ca3 and 2. 3 came from there, 2 went to there.
Will that always work?
Yes. So we have 3 of these. There was a 2 plus charge in each of them. What is my total positive charge? Positive 6. I have 2 of these. Each one was -3. What's my total negative charge? -6. They cancel out. When you do this, what you have to be careful of is if you get numbers that are reducible, like you would reduce a fraction, you cannot do this. So let's look at an example. What if we had calcium and oxide? I would take the 2, put it there, take the 2, put it there, and I would get Ca2O2. That is not correct. An ionic compound is always the lowest possible numbers that give you the same ratio.
Would it just be CaO?
Exactly. So you can reduce, both of these are divisible by 2. So you can divide each by 2, and you get CaO with little assumed 1 instead.
Now, for that, if you're gonna do that, can't you just move the numbers and then divide if you really wanted to? I mean, in that instance, it doesn't seem particularly useful.
Doing the division?
Doing the, moving the numbers. Like, you could still, I guess you could still move the numbers, but you just divide it.
You just know.
Yes, if you're able to look at it, I mean, at this point, for years, I can look at that and say, they have the same charge, I don't need to put a number. But if you're at the point where you need to write the numbers and switch them, you have to be responsible enough to realize, I have the same number. Or if you have two numbers that are divisible by the same number, sometimes it's not always 2, you need to do that, okay? It's the simplest possible ratio. So here's the next one. Barium nitrate. How do I write barium ion? Ba2+. Barium is here. It's in group 2. It forms positive 2 ion. What is nitrate ion? That's one of the polyatomic ones.
-4.
-3.
That's nitride.
Yeah.
This is nitrate. Nitrate was one of the polyatomic ones on the table. It's NO3. What charge? -1. Don't try to rationalize it. Trying to rationalize it is beyond this class. Memorize it. Okay? Nitrate is NO3 minus. Are my charges total 0? Do they total 0? No. So switch numbers. Put the 2 on the nitrate. Put the 1 that's implied here on the barium. You get Ba1. Nitrate has to go in parentheses. We have 2 nitrates. That 1 is not needed. You don't write 1. So we have BaNO3 2.
Is that the final?
That's the final answer.
I got a question.
Yeah.
I'm sorry. How do you get NO as a -1?
The table. Okay, memorize it.
Oh,
That's right. You
is it because 1 is negative?
don't try to go into because.
Okay.
If you want to, we can after class, but it's just going to make people more
I
confused.
understand.
I think once we get into Lewis structures towards the end of the semester, you may understand why. Potassium ion and sulfate ion. How do I write potassium ion? Okay, positive. What is sulfate? That's another one on the table. So it's 2 minus. What is the formula? SO. So are you able to look at that and without actually drawing the lines and everything, can you see what the formula is going to be? Or can you draw the lines in your head? What is it? K2SO4. That 2 comes down here, the 1 goes there, so we have K2, 2 came from there, SO4. Because we more or less have that, that's a 1. You don't need the 1. If you don't need the 1, you don't need the parentheses. So it's K2SO4. What would you call that? What's the name of that compound? Potassium sulfate. What's the name of that compound? Barium nitrate. What's the name of this compound? Calcium nitride. This one is nitride. Okay. Who wants to come up and write the formula for calcium ion and fluoride ion? You can have a different color if you want it. I got 4 of them. Nobody.
I'll try. I mean, I'll get it right.
Thank you. Don't have to get it right. You're not getting graded. Yeah.
from the.
You're good so far. You see fluorine? Top right corner. That's right.
Yeah.
Right there.
Okay,
Right there.
alright, so
Yeah. I have confidence.
I'm trying. He said, I don't need to write, right?
If you were going to put a 1, no, you don't need to write it. Is that right? Yes. Thank you. Who wants to do aluminum and oxide? Anybody? Thank you. Aluminum is there. I wouldn't have marked it wrong. Is that right? It's right. I mean, he just switched the numbers. Put the 2 there, put the 3 there. And he's done. Thank you. People are going to have trouble with this when you get home and do the homework. And I don't know why. Because you're probably sitting there right now saying that's easy. For some reason you don't want to come up and do it. But it's easy. You flip the numbers. You're going to get home, you're going to struggle. The homework on this type of thing is repetition. Meaning, write it over and over and over again. Which means if you do the first one wrong, what's going to happen to everything afterwards? It's going to be all wrong. So if you go to write the first one and you question what you're doing, what are you going to do? One of the two, okay? If you think you understand enough that if you look up the right answer, you can say, okay, that's how I do it. That's fine. If you're questioning what you're doing, email me through Canvas, and I'll get you back on the right track, the track that you're on right now, okay? I still don't know how people get off that track. You can help me figure out how people get off that track. Generations of students will thank you, okay? So, what's the formula for sodium ion and sulfate ion? Put them together.
SO4.
That's the name is sodium sulfate. Yeah. What's the formula? Na2SO4. Sulfate is -2. That 2 went on the Na, Na2. The charge in the sodium was +1. Put the 1 on the sulfate, it goes away. Na2SO4. Sodium and sulfite. So if sulfate is SO4, it's SO3. Yes.
So it's just gonna be
SO3 minus.
NO2, Na2SO3. No charge. Free. No charge. Remember, ionic compounds always have no charge. If you write an ionic compound that has a charge, something is wrong. Either that charge shouldn't be there, or it means your proportions, your subscripts are not right.
Wait, sulfite has no charge?
Sulfite does, but sodium sulfite does not.
What is sulfite's charge?
It's 2 minus, just like sulfate. So here's ammonium phosphate. Okay, what is the formula for ammonium ion?
NH4 or CO4.
And Somebody's taking it all the way. Say the whole thing? Whoever was saying it.
PO4 is
So phosphate is PO4 3 negative. So there's a whole lot of letters up here now. You have a polyatomic cation and a polyatomic anion. Parentheses, right. NH4 in parentheses, that 3 comes down, then right. So you put that, but then you say, oops, I had a 1, so I don't need a 1. If I don't need the 1, I don't need parentheses. So it's NH4 3 PO4. There's more letters here, but it's still just swapping the numbers. What if you had is there anyone that is not comfortable with this last one? Lithium and nitrate. No shame in asking. Do it in your head right now. If you can't do that in your head, nitrate is NO3 minus.
That would just be LiNO3.
LiNO3. They both start with negative, with 1 charges. This is 1 minus. Lithium is 1 plus. They're both 1 to begin with. They cancel out. You can do the little thing, but they're 1, so they just go away. So you have LiNO3. When you dissolve an ionic compound that has polyatomic ions, it behaves exactly the same. But you have to remember that polyatomic ion is more or less indestructible. So this is potassium, well actually, this picture here was our sodium chloride that we saw before. And you put the solid sodium chloride in, it breaks apart into sodium or chloride ions. I guess I don't have a picture of the sulfate. So, if you put in potassium sulfate and you dissolved it in water, what are you going to have floating around?
Potassium ions and sulfate.
Right, potassium and sulfate. This sulfate is stuck together. You cannot break that apart. So you're not going to get potassium and sulfur and oxygen. That sulfate is stuck together. It's going to float around as a sulfate ion. That seems horribly out of order. Or maybe I just got ahead of myself. What's the name of that?
Aluminum oxide.
Aluminum oxide. So now we're going in the opposite direction. Instead of taking names and writing formulas, you also have to be able to take formulas and go backwards to names. When you do that, you don't really have to pay attention to the subscripts unless you have to figure out which polyatomic ion you have. So here you can see there's aluminum and oxygen. Aluminum ion is always called what? Aluminum ion. An oxygen ion is always called what? Oxide. Aluminum oxide. So here's some names. What's the name of the first one? So you all know that it's sodium chloride, but now you know why it's called sodium chloride. It's sodium and chloride. The chlorine ion is chloride, so it's sodium chloride. What is this? Sodium nitrite. Nitrite is the NO2, that's on your table. What's this one? Magnesium chloride. Look, this one? Magnesium nitrate. This one? Barium oxide. And this one is lithium nitride. It's just the element, so it just becomes an I, like you very easily did for the oxygen and the chlorine. This is just a little flow chart if it's helpful for you. This is where the little ambiguity comes in. Some of the ones in the middle don't always form +2 charge. So in all the ones we did, I said, here's this element, what charge does it form? Lithium, you said, forms a +1 charge. If I say copper, you can't just say 2. You have to say it depends. Here is copper. If you combine it with oxygen, you can get CuO. You can also get Cu2O. In terms of charges, what would cause this difference?
You compare a positive one and a positive two charge.
Right. If copper formed a +1 charge, and you combined it with oxide, what formula would you get? You would have copper 1+ and oxygen that oxide, which would form Cu2O. The 2 would come here. What if you had copper with a 2+ charge and oxygen with a 2-? What's that formula? CuO. So the difference between these is in this one, copper formed a 2+ charge. It lost 2 electrons. Over here, it only lost 1. So it had a +1 charge. There are a fair number of these elements that form multiple charges. I'm really only going to hold you to iron and copper. I think there may be some, probably took them out of the homework. If you run across one that you gets marked wrong, because I say you had to say which one it was, and it's not iron or copper, point it out to me and you get points back. Okay? The ones you need to remember are iron and copper. Iron can form a +2 charge or a 3+ charge. Copper can form a +1 or a +2. And when you're writing these names out, you denote which charge it formed by putting in parentheses a Roman numeral for the charge. I see a lot of people that for the Roman numeral here, they put in how many are in what the subscript is here. That's not the same thing. So a lot of people would look at that and they would write out for me iron 1 chloride. That is not iron 1 chloride. The Roman numeral in here is the charge on the iron. So you have to look at that and figure out what that charge on that iron has to be in order to give us that formula. So looking at that, can you see why that iron had to have had a 2+ charge? Because chlorine has 2. And where did that 2 come from? It came from up here. When you swap your numbers, the subscript on that one was the charge on that one. So that 2 was up here, it's 2+. This one, there's a 3. That 3 was up here. This is our copper. Remember, there's a subscript 1 here. We just don't write it. That 1 came from here. And here, this is a case where it got simplified, right? So this was Cu2 plus O2 minus. When you swap them, you get Cu2 O2. So be careful, don't look at that and say there's a 1. That 1 came from there, it's a 1. It was a 2 that got simplified to a 1. So you have to look and see that it actually did get simplified. Does that make sense? So what number goes in the parentheses? The charge, not how many you have. I mentioned there are quite a few of them that can do this. This is just a taste. The ones I'm going to hold you to are copper and iron. The only exception is silver. But silver always forms a +1 charge. There are no multiple charges. All silver atoms are weird. Okay? So you definitely do need to know that silver has a +1 charge. The only 2 you need to know that form multiple are iron and copper.
Is 10 always going to be positive 2 as well? Or positive
10.
essence?
Say it again?
10.
Oh, 10. 10 here it shows +2 or +4. For us, it's going to be +2.
Okay. So everything else up there that has just 1 is going to form just the 1.
Anything that doesn't have anything written is going to form what you would think it should form. So iron, copper, silver. What charge does silver form? +1. Always. What's the name of that? Manganese. Manganese oxide. What's the name on that? Manganese oxide. So we said manganese oxide in both of them. What's up?
The charge is different.
The charge is different. Manganese isn't one that I said you had to memorize, but you notice something's up here. So what does that mean?
The first one that simplified it was I would-
What charge was on that? You had
Two.
+2. This started as a manganese ion with a +2 charge and an oxide ion with a -2 charge, which formed Mn2O2, which simplified Mn2O2 went to Mn. What charge was on that manganese here? 2+. In this one, why 4+?
Because it would make the oxygen 2 negatives to be flat.
Right. Oxygen is not a weird one. Oxygen always forms an ion with what?
2 negative.
2 negative. There are 2 of them, so where's our total negative?
4 negative.
4 negative. We only have 1 manganese. It has to completely make up for both oxygens. So there's only one thing it can be and be neutral. What does it have to be? 4+. Copper, chromium, we'll skip these. Let's look at the iron one. Iron is the one you have to know. What 2 charges can iron form? 2 and 3. Copper was 1 and 2. Iron is 2 and 3. So is this iron 2 or iron 3? Why?
This is 3
That 3 came from that. You may see, hopefully not in my class, you may see it online or somewhere, where when you write it out, rather than saying iron 2 and iron 3, they go back to the old Latin and say ferric or ferrous. That's another way you can do it. If you can get that right, I'll mark it right on a homework or something, but I don't suggest trying. That's one extra step you have to memorize. If you say iron 2 or iron 3, it's descriptive. If you know what you're doing, you can't get it wrong. But it's possible to get ferric and ferrous mixed up in your head. This is nitrate.
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 So it's iron nitrate.
If you want to go that way, yes. But it is iron, well, no. I think ferrous is the 3
I think if you don't know, we should know.
Which is what I'm telling you. If you put that on homework, I would actually have to look it up and see if you were right. Okay?
Well,
Yeah.
Get ready.
Okay, can we just start backtrack to number 4?
Of course.
They didn't acting like, so the CR was 6 and the O was 2, and that's how you got CR 03? I don't know.
Say that again. I think you were right.
The CR was 6 and the O was 2?
No. So,
I mean, yeah.
And the CR has to be +6.
yeah.
Plus 6 and negative, right? And then you do it and
You gotta
subtract.
reduce.
Yeah.
Yeah.
So, what is the charge on that O? Always.
Uh,
2 negative, right? And there are 3 of them. What's your total negative? -6. You have to come up with +6 to cancel it out, but you only have 1 chromium to do it. So what does the charge on that chromium have to be? +6.
yeah, that's what I'm saying.
Yeah, okay. But this one was not a simplified one.
Oh, yeah, oh.
Actually, it was, wasn't it?
Yeah.
Yes. Because if you have chromium 6 plus and O2 minus, you get CR2O6.
Okay.
So then that got simplified to CrO3. Email me, okay? Don't, the first semester I taught this, I gave them this homework assignment, and nobody said anything, and they didn't even complain about how long it was, okay? I'm looking at the problems in the book, and it says, well, it looks like, well, this shouldn't take all that long. I'll assign this and this and this. It took them hours and pages to write out.
I would simplify it.
It is. But they didn't tell me it was taking them hours and hours and pages, and that they didn't get the first one right, so they had hours and hours and pages of the wrong thing. Communication is key, okay? Your homework is much shorter now, but that also means you're going to have less practice. So if you struggle with it, ask me and come up with your own problems. There's probably a ton of it you can do online. There are probably little programs you can find to do it. Or if you have the book, you can find as many problems as you want. I think we can go. So that is, have we really only been here an hour?
Yes,
I
it's
know,
been
right?
5 hours.
Normally it seems like it goes really fast. This one seems going slow. Is everybody, we got plenty of time, I think. Is everybody on track? Somewhat.
I wish about sulfide, but that's, I'll ask for it.
Okay. If you have a question, think about what it is in your mind that's causing that question, and come up with a problem you would not know how to answer, so that we can put it up here and we can answer. So if you don't know how to write the name of a compound that has sulfate in it, how would you write the name of a compound that has magnesium and sulfate? What's the name of that compound?
I have,
Yeah.
I always have. How do you get with the CR, right? Remember you said it was like a -2 or something like that?
That was -6, +6. Cr.
Okay.
Chromium
I'm
is
trying to figure
here.
out how did you get, like, okay, oh, okay.
What's the question?
I don't think he does.
Does it make sense now that you said it, because you gotta go back to 6, yeah, okay. I'm sorry.
No, you're fine. You're fine.
It didn't make sense.
It didn't make sense to begin with, and as soon as you started asking the question, you answered your own question.
Yeah.
So it doesn't matter whether I tell you or you figure it out. If you hadn't asked the question, you wouldn't have figured it out. What else?
Nickel, platinum, and plutonium, I assume, the PT,
Yeah.
have 8 valence electrons and do not form ions. Why doesn't iron and copper?
Wait, back up. Why do they have 8 valence electrons?
Is they 1, 2, 3, 4, 5, 6,
Skip,
7, 8.
you skip these. For the
It's a
valence.
row under, isn't it? They don't
No.
form ions.
The transition metals, they go, they're.
There's
between
one,
2 and 3.
yeah. When you count valence electrons, it's 1, 2, 3, 4, 5, 6, 7, 8. These all have 2.
Okay, nickel, palladium, and plutonium were not on that list of ions.
They do form. You'll probably see. They definitely do. They're not on. They were not. Whoever made that periodic table did not consider them common.
Made them look like noble metals.
No, because what slide was that? Anybody have a number?
Go on.
This one?
Yes, that's cool.
But these are all blacked out or blocked out also
Why?
because
That's
they form +2.
Yeah.
These are the weird ones. These are not weird.
So there's 4 and +2 no matter what?
Yes.
You're bringing up way more questions than answers.
So the only thing shown on this periodic table are the weird ones. Anything that's not shown follows the normal rules that we learned last week.
Okay.
I'll save it for the break.
Molecular compounds have a different naming system. This one has much either fewer exceptions or no exceptions. I can't think of any at the moment. This is a molecular compound containing carbon and oxygen. That is a different molecular compound containing carbon and oxygen. Do you know the name of that?
Carbon monoxide?
Say it again.
Carbon dioxide?
Carbon monoxide.
Carbon monoxide. What's the name of that? That one you.
That's carbon dioxide.
Carbon dioxide. You know of, you heard of carbon monoxide.
Mhm.
So if that is carbon monoxide, and that is carbon dioxide, where do those names come from?
The 2 and the 1.
Subscript on the.
Right.
Like 2 charges.
It's
and-
just prefixes telling you how many of each one there are. So carbon, how many carbons are there here? There's 1. As you'll see, if there's a 1 on the first element, you don't put a mono in front. It's not monocarbon monoxide. It's carbon monoxide. Dioxide. So what would you call that? Sulfur dioxide. We haven't talked about the prefixes yet, but what would you guess?
Sulfur
Trioxide.
trioxide.
That's trioxide. What about that one?
Nitrous monoxide.
Nitrogen.
Nitrogen.
When we say carbon and sulfur, nitrogen monoxide.
Nitrogen dioxide. Nitrogen trioxide.
What do you think that one
It'd be like,
Dinitrogen.
Dinitrogen oxide.
huh?
Oh,
You can use you have to use the prefixes on the first one also. It's just if it's a 1, you don't put a mono.
Is it dinitrogen oxide or dinitrogen monoxide?
you always have to put a prefix on the last one. Always.
So it's
Dinitrogen monoxide.
That one's
What about that one? What do you think 4 is? You very well may not know it.
Tetraoxide.
Tetroxide, yes. It's tetra. But to make it a little easier, instead of saying tetraoxide, it's tetroxide. Just like it's not monooxide.
Can you not simplify the into a book?
No. You said, can you simplify?
Yeah.
No. Molecular compounds you cannot simplify. Because this is dinitrogen tetroxide. If you simplify it, you're going to get NO2. That is nitrogen dioxide. Those are very different things. What do you think that one is?
Nitrogen pentoxide.
Dinitrogen pentoxide. So here are some more. You already figured out the pattern, right? Here's our prefixes. Mono, di, tri, tetra, penta, hexa, hepta, octa. Penta, hexa, hepta, and octa you probably know. Nana you probably don't know. To you that may be your grandma or something. Right? And then deca you might know. Tetra is kind of the weird one. It's not quad or anything like that. It's tetra. And like we said, if mono is on the first element, you don't say it. So what's that called? Sulfur dioxide. That one. Nitrogen trifluoride. What that
Tetraphosphorus decoxide.
Tetraphosphorus decoxide. These are just, that's exactly what we're doing. There's your flow chart, it's one step. These are simpler, right? Just don't put a mono on the first one. And what is, if I say tetra, what number is that? 4. Make sure you can go in both directions. So up here we were just going in one direction. We were showing the numbers and giving the names. So if I say can that happen?
I don't think so.
Why?
Because you 12 would balance it.
Something simpler than that. What type of compounds are we naming here?
Molecular. So
Molecular.
That's not a molecular.
That's a metal. I can't use these prefixes for ionic compounds. So I need to rewrite my question. So if I have hexacarbon octa, what is hexacarbon octabromide?
6 carbons.
C6 or BR8. C6, BR8. It's no more difficult, it's just going the opposite direction. Name.
Sulfur.
Sulfur trioxide.
Sulfur
Fluoride.
Sulfur hexafluoride.
Dinitrogen
Tetroxide.
Yep. And number 4,
carbon
carbon monoxide. What's the last one?
Phosphorus pentachloride.
Phosphorus pentachloride. There are 3 compounds you need to know the name of that do not follow these rules. One of them, I really hope you already know. I hope you can pick it out from up there also. Okay? Water. That is it's an official, unofficial name. Okay? That is a chemical name. Ammonia, we said was NH3. What is ammonium? NH4 plus. Ammonia is NH3. Ammonium is an ion. Ammonia is a molecular compound. What's another name for ammonia? Following the rules we just did.
Oh, nitrogen.
It would be like trihydride.
Trihydride. Hydrogen is really weird, okay? For us, in this class, hydrogen is not going to act weird. Hydrogen can actually be written over here also. It can form a negative ion. We will never do that here, okay? So, it's weird, okay? Yeah. Nitrogen trihydride. And hydrogen peroxide is H2O2. That one you may or may not. You've certainly heard of hydrogen peroxide. You may or may not have known of H2O2.
Why is it hydrogen dioxide?
Yeah.
Say it again?
Why isn't it hydrogen dioxide?
Why dihydrogen dioxide?
Because peroxide is a polyatomic ion that was not on your list. Peroxide is that. That is a thing on its own. So if you have H plus, O2, 2 minus, you get H2, O2. That one I got the answer to. Yeah.
It's funny, I saw this, talking about the names, so I saw this video of a guy going around getting people to sign like a protest against hydrogen monoxide to see if anyone would recognize
Oh, yeah.
what that is.
Yeah. Consuming too much dihydrogen monoxide will kill you.
They're like, it's in everything.
It's the largest killer of any chemical compound in the world.
Lots of drowning.
It's drowning.
It's in the
Oh,
rain,
okay.
it's in the
Yeah,
ocean.
if you inhale too much dihydrogen monoxide, you will die. You can also sell people dehydrated dihydrogen monoxide, just to add water.
But it's funny, there's a bunch of people signed a protest against it. It's like, we gotta get rid of that.
There's all kinds of, I mean,
Iron?
what is that?
Bunch of iron.
Bunch of iron.
6 irons. So
If, what did we say Fe3 plus was called? That's one of the things that you don't have to know.
iron.
It was ferrous. So what is that?
Ferris wheel.
The Ferris wheel.
Aha.
Oh my god, that's one of those chemistry jokes.
I think it was a Ferris wheel. It was either a Ferris wheel or a Ferric wheel, but a Ferric wheel is not funny.
No, Ferris wheel is very
Okay,
funny either.
let's take a break. We will start at 25 after on that clock, so 10 minutes from now.
Ferris wheels are strange.
Actually, I think it was there. I think it was there.
So why don't
I think it was there.
the defense count as covalent? Valence. Why don't the B
I used to go to gym
duals count as valence?
You can make a file. So, remember we talked, so that deal, what's the number on that deal?
One less.
One less. And so, let me draw. I used to have a slide up there that explained this. It was just confusing people.
Iron should have 8 valence electrons.
So, what the number, we had a name for what the number represents. Do you remember? It was the principal energy level. Okay? So when you add the orbitals going out, as the number gets larger, they get further and further away. They just kind of stack on top of each other. Okay? So when you add, if you have a nucleus that for some reason is not falling apart, and you get, there's 1, 2, and 3, and so iron is in period 4. So here is 4, and we're going to say there are 2 s electrons up here. You see that? Where do the 6 next ones go?
I assume on the level below.
Exactly. They're going to go in the D and the 3. So they're inside. The valence ones are only on the outside.
It's the 2, 8, 18 thing. I remember it wasn't technically wrong.
2, 8, 8.
The levels.
Oh, how many go in?
Yes, it just fills up 1 before it comes back.
Yes.
Because it does
Oh.
2, 8, 8, 8, well, 2, 10, 10,
Yeah,
8.
it's a matter of electrons want to go with the easiest place they can. And it's easier for them to go in the 4 S's before they go than it is for them to go into the 3Ds. But it's easier for them to go into 3Ds than it is to go into 4Ps.
So then they have 2 valence electrons,
Yes. Iron has 2 valence electrons.
which is why most transition metals should form a 2 plus.
Correct.
So why would they do a 3 plus?
For some reason, some transition metals will also lose one of these.
Is there an answer for that?
Not, there, I'm sure there is. I don't know. That one I probably did know at some point, but I don't remember. And for some reason, silver has 2, but it will only lose 1.
There's a lot to memorize this chapter.
Sort of. I mean, it's a lot of rules.
Yeah.
And once you do some, they're going to become second nature. Which is why it's important to get them right the first time, so that you don't learn the wrong habit.
Can you check this out? Do it. This doesn't have to be 1 is that.
Yes, exactly.
Yeah, so then it's not to.
Yes.
And then this.
You did it the mathematically correct way, got that? You didn't necessarily have to do, you did difficult algebra. Okay. Can you see logically why it was 50-50?
Yeah. Yeah, because this is like.
Exactly.
I just want to make sure I was.
Well, no, that's, a lot of people wouldn't be able to do that algebra. Do the one line, that's exactly right. But you would not be have to do that level of algebra.
Yeah, I guess if I was like, just to make sure I got it.
I mean, I don't think you'll see any,
It wouldn't be out of question if say that one was not.
say you give one of them, say that one's 60, find the other one, or, but if you have one variable, it's easy. When you have 2 and you have to substitute, then it's more difficult.
100 minus 60.
You would.
Gotcha. It only
There's
exists in two forms. So
Well, I've heard of it,
the other
yeah,
one
they
has
do
to
all
be
kinds of stands and everything, yeah.
There's signs and card invitations.
Number 4, yeah, or number 3. You do the 60, the 80 and 69. You do that times 69 and add it, and then, no, you don't.
So my question was, sulfate to sulfide, you said they were the same charge.
Yes.
How is that so?
You'll see when we get to Lewis structures.
Because I mean,
Yeah.
the method I was using was,
And then do.
total
I know, but I'm always thinking.
and it seemed to work
And that's
for
your
some
point.
compounds, except for it didn't with sulfate to sulfide.
It's a matter of,
We,
you
my,
say you shake sulfate.
How many electrons? Yeah, we just went throughout the house and changed every single clock, even her one time, just
Use the
years
charge.
behind without her knowing.
So, yeah.
How many gallons?
I leave 45 minutes.
How many gallons?
I don't know.
It's all.
And it's really-
I don't know what it is.
So if you have sulfur, how many total valence electrons?
Sulfur, how many?
Sulfate, so there's 4 ounces. So there's 5 between 6.
This one, I'm not able to flex it. So
30 valence electrons total. You start drawing.
And then this one, that was people.
There are rules that you're going to have. You're going to try to use the purity electron to satisfy the rules. You're going to use extra to satisfy the rules. Whereas you add those extra electrons, you're adding negative charges.
It does contain
Too much charge.
been allowed in
When you try to do with it,
What is that stuff?
you'll see. Once
You're drinking it.
draw it out, and you see it right in the freeze.
Probably the most stressful part of the.
Something that's
is
too
that he's getting corrected that
Yeah, suck it, I need something.
name or any motivated by all this information, so I'm just like, oh, I don't know who this could belong to.
Yes.
Yeah, so you pick the one with the smaller.
I was like, what? You're fine, man.
Oh, Lord.
Somewhere in there, everything is true. I don't know where. Actually, I don't know. I'm gonna do something else.
I was so hungry in the class.
I went snack and just chill out my body.
I need some party.
I got a lot of great people.
I got some nuts.
Oh, my mom, she works at GRU, she said that the drive-through window for jury. Yeah.
People there are.
It's like, wait.
Like, I love it when someone comes, like, when someone comes up to me and says, oh, I need a bill on my mom's bill.
I just got my phone.
Yeah, I was like, who are you? Yeah, like, they'll come up to me and be like, I need to.
I had found this public right before that. And it was about 1 second time, but.
Okay. Now that you've ruminated on that, what are your questions? Any? Okay. So, we're going to move on to acids and bases. But we're just going to touch the surface of acids and bases. Acids and bases are going to have their own entire lecture. Say it again?
Probably dangerous.
Oh. They're going to have their entire lecture to themselves later on. basically today all we're going to talk about is naming acids and bases. And these are probably the ones that you're going to kill me over. Okay. When you add an acid or a base to water, acids and bases are ionic compounds. They break apart into their ions. This is hydrochloric acid. There's a hydrogen ion and a chloride ion. Put it in water, you get a hydrogen ion and a chloride ion. What makes something an acid is this hydrogen ion. We're going to talk more about this, about why. Don't worry about this statement too much this lecture, but this doesn't actually exist. It grabs onto a water and it can exist as that, but don't worry about this statement today. When you put acids and bases in water, they react together. You've certainly at least seen baking soda and vinegar. What happens? Bubbles and foams. What is the acid in that reaction?
The baking soda.
Which one?
Acids and vinegar.
The baking soda is the base.
Baking soda is the base.
Yeah.
What is it? Do you know another name for vinegar? It's acetic acid. Once you know that, clearly that one's the acid. Yes?
Can you eat a lot of it when you die?
It depends on how much you eat, yes.
Because I eat all my food.
It would be more of a, either you die then,
You'd have to drink like several gallons maybe, like, in a sitting.
vinegar is not like, it's not a strong acid. Okay. One, we'll learn in the other lecture that there are actually strong acids and weak acids. Vinegar is a weak acid and it's very dilute. There's not a whole lot of it in there, it's mostly water. So you'd have to drink a lot of it.
How many pickle jars are we talking here?
I don't know. But in a later lecture, you'll find, we'll learn if you were to drink a whole bunch of vinegar and you screwed up the pH of your body, how you could fix it just by breathing. You can look forward to that.
By breathing.
By breathing.
Hyperventilate, carbonic acid.
So we looked at acid already. When we put acid in water, what did it form? When we put an acid in the water, what did it form? We put hydrochloric acid in water, what did it form?
Acidic water?
What ions did it form? Hydrogen ion and chloride. We said what makes it an acid is the fact that it makes a hydrogen ion. What makes a base is a hydroxide ion. Hydroxide ion is on that table. Okay? Hydroxide ion is very important because all bases are going to make this hydroxide ion. So this is sodium hydroxide, breaks apart into sodium ion and hydroxide ion. So this is our hydrochloric acid before we put it in the water. This is HCl, H bound with Cl, put it in the water. The chloride ions are now floating around. We said the H plus actually will bind, stick to a water, and form H3O plus. So that's what it looks like in your little dropper bottle of acid in the lab. This is a base. This is a weird base. This is what? That's ammonia, NH3. NH3 is actually a base. It doesn't have an OH in it, like the sodium hydroxide did, but when you put it in water, it forms what? Ammonium and what? Hydroxide. So it accomplishes the same thing. Bases form hydroxide.
Always.
Like always. like we had oxo anions, there are also oxo acids. These you do need to worry about. It's not, you don't need to worry about the fact that they are oxo acids. You need to worry about them because they're important acids. Okay? So there are nitric acid, sulfuric acid, carbonic acid. You certainly heard of sulfuric acid. You might have heard of carbonic acid, and maybe you've heard of nitric acid. This is acetic acid. We're going to definitely use acetic acid in the lab, but you don't need to worry about it too much. Basically, it's this big molecule, and this one hydrogen over here can break off, and when it breaks off, it forms H+. So that's why acetic acid, even though it's this big thing, forms H+. This one is able to come off. So these are some names. Can you find a pattern here?
The IC acid.
Ic acid, yeah. So just look at the first four here. Hydrofluoric acid, hydrochloric acid, hydroiodic acid, hydrosulfuric acid. If I put based on that pattern, if I put that, what would you name that acid? Based on the pattern there. Hydrobromic acid. If you have hydrogen with an element, just an element, not a polyatomic ion, just an element, but hydro, element, ic acid, hydrochloric acid, hydrofluoric acid, hydrochloric acid, hydrobromic acid, hydroiodic acid, hydrosulfuric acid. Yes?
Can acids be solid?
Yes, they can be. HCl, in its pure form, at least at room temperature, is a gas. You can't, but it's possible to buy hydrochloric acid condensed in a bottle. So it's condensed gas. In that bottle, it's actually a liquid. I actually accidentally breathed some of that in once. It was not fun.
Oh, what did it make you do?
It burned my throat.
Um,
It was not fun. So if you have hydrogen with an element, hydro, element, ic, acid. When you have polyatomic ions, is where it gets tricky. What is that polyatomic ion called? Do you remember? CO3. Carbonate. It's on that table. It'll be easier. This stuff will make more sense once you have that table memorized. You'll be able to go back and forth. CO3 was carbonate. When we turn that into an acid, we have carbonic acid. What was NO3 called? Nitrite. Not nitrate.
Nitrate?
I was thinking nitrate instead of nitrite. It is NO3 is nitrate. Nitrate makes nitric acid. What was SO4? Sulfate. Sulfate makes sulfuric acid. What is a pattern that you see?
Eights calls X.
Eights make X. What was SO3 called?
Nitrite,
Sulfite. ClO3, I don't think that was on your list. That is chlorite. Ites make us acids. Okay? On your file online, with your polyatomic ions, there are 3 oxoacids that you are required to know the name of. There's sulfuric acid, sulfurous acid and nitric acid. So if I gave you the name sulfuric acid, you would be required to give me that formula from it. But you also need to know the pattern, that if the polyatomic ion is an 8, it makes an ic acid. Sulfate makes sulfuric acid. Ites make us acids. Sulfite makes sulfurous acid. So, what would you call HNO2? Nitrous acid. What is NO2 anion called? Nitrite. This one was nitrate. One less oxygen is nitrite. And ites make acids. It makes sense to you now, hopefully. It's not going to make as much sense when you get home and you do the homework. Just remember, it's not that complicated, so don't make it more complicated than it is. Look at the polyatomic ion. Was it an 8? Was it an ite? If it was an 8, make it ic, add the word acid. If it was ite, end it with us, and acid. There's a key difference. What is the name of that? It would be the acid name, not the molecular compound. What was that? Hydrochloric. So what's the rule? Hydrosulfuric acid. This is hydrosulfuric acid. Is hydrosulfuric acid the same thing as sulfuric acid? No. They are very different things. Sulfuric acid, H2SO4. So that hydro is very important. That hydro tells you it's H2S, not H2SO4. So that's a key. When you see that hydro, you know you're dealing with the element, not a polyatomic ion. And like you already realizing, there are a lot of little ways this can go. That's what I mean. When you find one that doesn't make sense to you, you don't know whether you're doing it right, this is a really easy type of thing for me to correct through email. So just email me. Here are some this is another flow chart for you. The flow charts are your thing. What would you call that? Hydrobromic acid. It's an element with hydro elementic acid. Hydrobromic acid. This is a polyatomic ion. It is not on your list. You'll probably never see it again. But I'm telling you right now, this polyatomic ion is called selenate. This is selenium with an 8, selenate. What would you call that acid based on the rules we just learned? Hydroselenic acid. What I like to do, and I really do this, is I say, well, it's a polyatomic ion. What are the rules for that? What's an example that I can fall back on? And I always fall back on sulfuric acid. So I say that's sulfuric acid. So if sulfate makes sulfuric acid, what does selenate make? Selenic acid. what would hydroselenic acid be?
It would be H2SE. No?
Where is, yes,
Yes?
yes. So, the selenium ion is 2 minus, so you have H, so you get H2SE. That's hydroselenic acid. This is selenic acid. What's this one? This one's a really common acid. I don't think PO3 was on your list of ions you need to know, but you'll probably run across it a fair number of times.
Be a phosphate, no.
PO3,
It's phosphate, right?
PO, yes, yes. No. No.
Phosphite?
Phosphite.
So, and phosphorus acid.
Phosphorus
Phosphorus.
acid. What would phosphoric acid be? PO4. PO3 and PO4 were not on your list. But if we say PO3 is phosphite, phosphate has to have one more oxygen. So that's PO4. What is phosphoric acid in? Anybody know? Something we run across a lot. It's in this room. Nope. Nope.
Lights?
Nope. I'll give you a hint. It's something in that, we'll call it groups or columns, right?
Is it soda?
Coke. Look at that. Whose Coke is that?
Oh, that's scary.
Read the ingredients. Is phosphoric acid on there? Probably, hopefully.
Yeah, number 3.
Number 3.
Pretty high up there.
But the vast majority of that is water, so everything else below that is tiny amounts. But there's phosphoric acid in Coke. That's not a bad thing. A lot of people are chemophobes. They're scared of anything that has a chemical name, right? Everything has a chemical name. Water is dihydrogen monoxide if you want. You can scare people with that. Phosphoric acid being in there is not a bad thing.
What about this phenylalanine? It has a specific warning for.
Yes. That sounds scary, doesn't it? Does anybody know the reason why that's on there?
What is it?
Phenylalanine. There's probably something about phenylketonuria. Warning this has phenylalanine.
Probably something like cancer.
Phenylketonuria. Does anybody know what phenylalanine is?
I can't even say that word.
Like a felony?
Phenyl.
No.
That's like a pH. Wow.
Like a pH.
Spell it out.
Phenylalanine.
It's like sugar.
Is it a warning label?
Is it an artificial sweetener?
No.
Is it one of those California cancer?
Well, in this case, it's related to it. Okay, but phenylalanine is a lot less mundane. It's a lot more mundane than that makes it seem. Phenylalanine is an amino acid. Do you know what amino acids are? They make up proteins. There are 20, 23, 24 amino acids that make up all the proteins in your body. Everything in your body that does something is a protein, and they're made up of a small number of building blocks. Phenylalanine is one of them. That's not scary, right? Phenylketonuria are people that have a genetic disease that can't metabolize it correctly. If you can't metabolize it correctly, it builds up in your blood system, bloodstream. What filters your blood? And what organ? Kidneys. So if you have a whole bunch of something building up in your kidneys, kidney stones. Phenylketonuria, if they eat too much phenylalanine, will get kidney stones. So if you don't know in here that you get kidney stones, you don't know you're phenylketonuria, that warning does not mean anything to you. There's nothing to be worried about.
Not yet.
Any meat that you eat is going to be full of it.
So what, do they just take medicine for it or something?
You would just avoid as much as you can't avoid eating
Well,
meat.
I was gonna say, how do you avoid protein then? Like,
You
do it.
can, but like you alluded to, phenylalanine is a little part of aspartame, which is artificial sweetener. So if you can avoid aspartame, you will avoid eating a whole lot of phenylalanine.
Oh, does it have like like an unnaturally high amount or something?
Aspartame is made of, it's basically a little tiny itty bitty protein. And one of the amino acids in that protein is phenylalanine. So you get an abnormal amount of it when you eat.
As opposed to just like eating steak or something?
Yes.
See, aspartame is number 4 here. So there's probably a pretty decent amount of it.
Now, where does the scare for aspartame come from? People say it called it cancer.
Let's talk about it after class. Basically, it makes formaldehyde in your bed.
California says it gives you cancer.
Everything leads to cancer.
Including dihydrogen monoxide. What would you call that? Hydrochloric acid. How about that one? Nice catch. And your calculator fell in your backpack, so it didn't hit the ground.
Oh, nice.
Nitric acid?
Nitric acid. If that's nitric acid, what's that?
Nitrous acid.
Nitrous acid. So it all comes back, if you can remember that the anion that has the 8. If you can remember nitrate is NO3, you immediately know nitrite, you know nitric acid, and you know nitrous acids by memorizing one thing and a couple rules that you can apply to all of them. What's that? Sulfuric acid. What is sulfurous acid? H2SO3.
Would it ever get on to H2SO2?
Not for sulfate. If you look up a table, I think it's part of what I blacked out in the slide. Chlorate chlorate can actually go up 1. It can go down 2 or 3. You know, it's a huge range of them.
Wasn't it like per sulfate or something?
There's perchloric and there's hypochloric. I think perchloric is, if chlorate is ClO4, perchlorate is ClO5, I think. And hypochlorite,
I think it's on the slide, like, there are things like 2 slides back.
yeah. Chloric would be chlorate, chloros would be chlorite, hypochlorite. What is, you know the formula for bleach? The name, chemical name for bleach?
No, I don't.
Sodium hypochlorite. So it'd be NaClO, sodium hypochlorite.
Maybe you can mix it with ammonia and that does bad things.
Very bad thing. Don't do it.
Causes cancer.
YouTube it, don't do it.
Do not be in a
Yeah.
What's fluoric acid?
You've seen it?
I'm just wondering.
Fluoridic?
What's the formula for it?
Fluoridic acid?
Yeah.
Like
It's fluoride. As an acid.
hydrofluoric?
Okay. Yeah. I guess. Yeah.
I mean, I
Not
guess
clear on when you do or do not have the high.
fluoridic acid, if
If it's,
Florida is Fl, then fluoridic acid would be HFl.
If it's not a polychloride.
Okay. Jokes don't, this confuse you if you don't get them. Never mind that. Some people got it. Okay.
In the, sorry, in that slide, so, I mean, would I be correct in saying that, one, that has a, like, 1 or, you know, they measure 1, 3 or 4, it's ick, or 2 would be us?
No. Because remember, phosphate, nitrate is O3, sulfate is O4. And so H2SO4 is an ick. H2SO3 is an us, but HNO3 is an ick again.
Oh, okay.
So that's why it all comes back to remembering which ion is the 8. The ATE 8. If you can remember that and some rules, you got the rest. unfortunately, that's the easiest way to do it, rather than memorizing everything.
So return is an 8.
Yes, remember which ion is an 8. Sulfate, nitrate, and chlorate, I think, are the ones on nitrate, sulfate, chlorate. Are the 3 that are on there. Last thing is calculating molecular weight. This is an easy one. Okay? The atomic mass is what's given up here. But molecules are made up of multiple atoms. So all you're going to do is add up the masses for all the atoms in your molecule, figure out what number it is, and that is your molecular weight. So, just like this said, you're going to add them all together. But mathematically, there's an easier way to do that. Multiply the mass of the element times however many of them there are, and then do it for each element and add it together. So this is just the molecule H2. Hydrogen is 1.01. Some tables will round to 1.01. There are 2 of them. 1.01 times 2 is 2.02. The molecular weight of H2 is 2.02 AMUs. Sodium chloride, there's 1 sodium. Sodium is 22.99. That's it up there. Chlorine is 35.45. There are 1 of them. Add them together, 58.44. So let's make a complicated one. Somebody, first of all, we're doing, let's do a molecular compound, then we can make it a whole lot more complicated, as complicated as we want. So name a nonmetal. Say it? A nonmetal. Nonmetal.
Z.
Tellurium is a metalloid. Let's avoid that.
Iodine.
Iodine. So how many iodines do we have?
12.
No.
Name another nonmetal.
Neon?
Not a noble gas. Noble gases can't make compounds.
Silicon.
Silicon. How many of those we got?
2.
15 was first. Name another one.
Phosphorus.
Phosphorus, let's put, you don't have to, I am obligated to do this correctly. How many phosphorus do we have?
1.
27, and I think we had, there was 15 silicons. Let's add 1 more.
Carbon.
Carbon.
1.
1 carbon. 1 carbon. Thank you for being quick.
You're welcome.
So we don't need a 1, right? So, how would you find the molecular weight of that monstrosity?
Just add multiply molecular weights.
Multiply them out. So what is the atomic mass of carbon?
12.
12.01. How many carbons do we have?
1.
Times 1. Phosphorus is next. What's the atomic mass of phosphorus? 30.97. I'm trusting you on this. And how many phosphorus?
7.
27.
You're giving it an arrow.
Silicon. What's the atomic mass of silicon?
28.08.
28.08.
Are we rounding?
I would be consistent.
Then it would 0
No, we did around the other one.
Yeah, that we need the significant digits.
Yeah. With this, what I would do is pick one number of sig figs and be consistent, and then make your answer match whatever you picked. So here we're picking 4. And go with it.
Okay.
So how many silicons do we have?
15.
15, and then we have iodine. Atomic mass of iodine is 126.9, and we have 12 of them. 12.01 times 1 equals 12.01. What's 30.97 times 27?
Answer is 27.92.
The whole thing at the end?
Yeah.
Okay. 27,
92.35.
92.35. What are my units?
AMU.
AMU.
We have to have 4.
And we're gonna round it to 4 sig figs, so how do I do that? 27.92 AMU. Is everyone comfortable with what she did? So somebody do this for me. 836.19, what's this one? 421.35, and last one. Whoa, okay. There are too many numbers there. 22.8. So she added those 4 numbers up and got that number. So it doesn't get more difficult than that, it just gets longer. Okay? Questions on that? Okay. So we can